Hello everyone. Really nice to meet you. I'm Krzysztof, and this is my colleague Tomasz.
Hello everyone.
We work at Software Mention in React Native open source team, and we work together on React Native Reanimated. But today we are here to tell you more about Fabric.
So Fabric is a new thing in React Native world. It's totally a buzzword of 2022. We hope to give you a more pragmatic look on the topic and also share our knowledge on the current state of Fabric. Today, we are going to show you the app migration process from the perspective of mobile app developer. Then we will explain the differences between the old and the new architecture. And finally, we are going to tell you the migration story of our open source libraries, so we can see better what it looks like from the perspective of open source.
We think that the best way to learn is by example. Our today example will be the migration of the application to Fabric. Let's imagine a situation where you sit comfortable in your chair, then your boss, with excitation in his eyes, tell you that he just seen an incredible tweet from Elon Musk. Boss said, if Elon Musk said that Fabric is great, so let's migrate our application. So you reply to your boss, yeah, sure, let's do that. Your boss left the room, and then you need to check one little thing. Right question. Hopefully, you found the reactnative.dev website, and you started reading it. You found that Fabric is a new renderer, and this is a part of the new architecture.
So the new architecture of React Native consists of two things. First, turbo modules, and then Fabric. Turbo modules are the successors of native modules, which are mainly used for calling platform native code from JavaScript. And then Fabric, this is a code name of the new React Native renderer that is built on top of JSI. So what does the renderer do, you may ask? Imagine the following component tree declared in your React JavaScript code. In order to show it on the screen, React Native needs to build a corresponding structure of native platform views on the native side and then mount it. So obviously, this is platform specific. So the mounting part of the renderer has two separate implementations, one for Android written in Java, and the second one for iOS written in Objective-C++.
Let's go back to our example. In the documentation, you found information that you need React in version 68. So you quickly update your version in package.json, run yarn. So far, everything works. Well, you compile your application. This application launched without any crashes. Just work. Easy, easier than you thought. But just to be sure, you decide to check if Fabric is really enabled. You found, obviously, on Stack Overflow how to check it. So you run the app again, but bad news, your app still doesn't use the Fabric. You check the documentation again. Oh, silly me, I haven't noticed information about flag to enable Fabric in the app.
So it turns out that starting from version React Native 68, React Native supports both architectures. And by default, the old architecture is still in use. So if you just abrogate to React Native 68, it doesn't mean that you run the new architecture. You may be still using paper, which is the old architecture. So if you want to use Fabric, then you need to opt in manually by enabling the new architecture. And here's how you can do it. Well, on iOS, you need to set RCT new UART enabled while running pod install. And for Android, you need to change a single Boolean flag in Gradle properties.
You have set those flags, so everything should work now. It's time to check the application. iOS first. Quick compilation, launch the app, and great success, everything works. With enthusiasm, you go to check the Android, and then you see this. Explicit this. Missing NDK. What does it mean? This is native development kit. Since the version 68, React Native has a common code base in C++ for both platforms. Also, you need to compile it because React no longer provides compiled binaries. That's why you need to have NDK toolchain on your machine. Now, on both platforms, we can build React Native from source. So let's install NDK on your machine and build the app again, and compiled successful.
Great, so the app has compiled successfully, but we still have some errors and warnings. That's because we still need to make some changes in JavaScript. If your app uses set native props, find node handle, UI manager measure, or UI manager dispatch view manager command, you will need to migrate those as well. Luckily, this is pretty straightforward and also well documented on the reactnative.dev website.
Now, you have updated your JS code base. Should be enough. Let's run the app again. But why? If the view hasn't been migrated, a red square with label unimplemented component will be displayed instead. This means that all of your app dependency needs to support the new architecture. The community has a lot of work to do to provide support for Fabric. We will give you a high-level overview what needs to be done to save your time. Let's consider what is difficult in migration process for different types of libraries. In the beginning, the good news, if your library is JS only, so it doesn't use native view, etc., probably you need to do nothing to make it compatible with Fabric. In opposite to case, when your library uses, for example, native components.
So now let's see how to migrate native components like map view, web view, or video component. The most important change is the introduction of React Native code gen. The idea is that you define the interface of your native component in a spec file. Specs can be written in Flow, which is a dialect of JavaScript developed at Facebook. If you don't like Flow, instead you can write a spec in TypeScript. In fact, Nicola Corti also announced this yesterday. However, keep in mind that some of the features may not be supported yet by the TypeScript parser. So let's see an example of a spec file. I took this one directly from React Native code base, so that's why it's written in Flow. This is for the switch component, and here's only the beginning of it. Important thing here is the name of the spec file, which needs to end with nativecomponent.js, so that the code gen can automatically find it. Then some imports, as usual. And now the main part. We need to define the props of the native component, along with the types and the default values. The main purpose of CodeGen is to ensure the type safety between JavaScript and the native side. So basically, the spec file serves as the single source of truth. Currently, CodeGen supports numbers, strings, arrays, custom objects, and even things like colors or image sources. And once you define the spec, React Native CodeGen automatically generates all the classes and interfaces that you need to extend or implement when providing the implementation of your native components. And apart from the props, you can also define the supported events. which can be either bubbling or direct, and specify the type of the event payload as well. Finally, you need to call CodeGen native component function and export the native component. This works kind of similar to require native component from the old architecture. Also, you can pass some additional configuration here. Apart from props and events, CodeGen also supports commands. Commands are just like imperative API for interacting with your native components. For example, scroll to command for scroll view. There is also a function called CodeGen native commands that lets you do exactly the same, and you need to use it in this case.
And what's about migration of Fabric of native modules? As Tomek mentioned before, turbo modules are successors of native modules. But what is the difference between them? In the old architecture, every time when you call the native method, the invoke was serialized to JSON. This string contains the method name and all of the arguments used by this method. Then React sends this JSON via bridge to the native site. Over there, those objects are deserialized on the native site into Java or Objective-C objects. Obviously, it takes time. That's why native modules were mostly asynchronous. However, turbo modules use GSI instead. So there is no serialization. So this is much faster and better approach. All native modules built in React Native were rewritten as turbo modules. So if you need inspiration, make sure to check them out. Native modules definition can be generated by CodeGen as well as native views. The most important thing here is that we can define types of the arguments of the functions and the returned value by them.
Turbo modules are actually built on top of JSI, in particular using host objects. In general, JSI or JavaScript interface is a C++ API for interacting with JavaScript virtual machines for interop purposes. For example, using JSI, you can implement a JavaScript function that is implemented in C++. An interesting fact is that JSI is also available on the old architecture. In fact, React Native Reanimated was the very first third-party library to use JSI, starting from React Native version 62. So now, for the last part of our talk, we would like to tell the migration story of open source libraries here at Software Mention. Again, we want to emphasize the fact that the vast majority of community libraries still needs to be migrated one by one. Currently, this requires obviously some additional effort, and there are totally no automated tools for doing so. So in fact, this is a serious blocker for all app developers who want to enable new architecture in their apps. That's because they still need to wait until all of the dependencies that they use are migrated. The mission of our company is not only to develop great open source libraries, but also to pave the way and set an example for other React Native developers. So when it comes to Software Mention, libraries, we started the migration process back in 2021. We really wanted to prepare our libraries ahead of time, so they are ready for the new architecture, and early adopters of Fabric can use it in their apps. This was extremely important for us, since Reanimated, Gesture Handler, and Screens are among the most popular React Native libraries. And And speaking of our open source libraries, we would like to thank Shopify for their continuous support over the course of the last few years. With their help, we managed to expand our open source team, deliver many critical features to the libraries that we maintain, and now we are ready to pave the way for adopting new architecture among the community libraries. We are so happy to have Shopify being a part of this community and making a real impact. Thanks.
So let's talk more about our libraries. React Native Screens. This library provides platform navigation components to React Native. Moreover, this is a dependency for React navigation. During the migration to Fabric, we encountered some issues. For example, we developed that Fabric changed the order of mounting or unmounting the child views. Now, this is bottom-up instead of top-down. Also, we need to support both architecture with common code base. Is it possible to achieve it in a couple of different ways? But we wanted to eliminate duplication of code as much as possible. For iOS, it's simple because we can use ifdefs. Unfortunately, we unable to do the same in Java. So we used a Gradle source set on Android. Another thing that React Native core hasn't provided a possibility to auto-link your library on Android yet. This means you need to manually link each library in Grade. But fortunately, we found a workaround, so our libraries work out of the box. Nicola said yesterday that they are working on auto-linking, so we are hope that it will be available soon, but in this moment we have our own workaround. So, well now, if you want to change the architecture, you just need to change a single flag. Our colleague Kuba wrote an article on our blog where he described in details the story of migration in the Screens library.
Another library migrated by our open source team was React Native Gesture Handler. This is a library that provides a declarative API for exposing platform native touch to React Native apps. On the iOS, the library creates and attaches UI gesture recognizers to native views. And one of the issues we've had with the new architecture was related to the fact that React Native has this cool optimization technique called view flattening. So view flattening is an optimization technique done in React Native renderer to avoid deep layout trees in order to minimize the number of views and therefore improve the performance of the app and also lower the memory footprint. So in case you try to attach a gesture detector onto a view that will be view flattened, we need to detect such cases and show a warning to the user. And also the library, the React Native Gesture Handler, comes with 2 native views, but we already knew how to migrate those due to the fact that it was previously done in React Native Screens by our colleagues.
Let's talk about Reanimated. This is the most complex and challenging library we have migrated due to the fact that Reanimated is heavily integrated with the React render system. So we needed to adjust some parts of our logic to pass Fabric requirements. Fabric changed the shadow tree behavior. Now it keeps shadow nodes in C++. And we need to trigger layout computation from reanimated C++ code on UI thread. What is shadow tree? The shadow tree is this is something between JS view tree and the native view of tree. Okay. We also had to find a way to prevent React and Reanimated from overwriting each other's changes on this shadow view tree. Okay, that was the hardest problem, I guess. Finally, Reanimated needs to receive event as fast as possible to apply changes in the same render frame. For example, scrolling events from scroll view. To achieve it, we implemented a pull request to React Native Core in cooperation with folks at Meta. So thanks, Meta. So we successfully have released Reanimated 3. On our blog, we described how to use Reanimated 3 with the new architecture. So let's look at the video prepared by Tom. This is an example of cooperation our 3 libraries running on the new architecture. So the header is from screens, gesture handling provided obviously by gesture handler, and Reanimated connect all of it together and animating the changes.
So there we have it, 3 libraries already ported. So far, so good, but there's one more little announcement. Our open source team is also working on Fabric migration of React Native SVG. The main person behind migration is Wojciech Lewicki, who also helped us a lot when preparing for this talk, so thank you, Wojtek.
We talk about a lot about new architecture, but is it worth it? Does Fabric bring to us any benefits? The quick answer is yes. And the new architecture gets rid of bridge. So no longer bridge, no longer serialization, and it does mean less delay on the methods invoke. The codegen take care about type safety. Fabric comes with a bunch of improvements. For example, the first render of your application is synchronized. Well, the blank startup screen disappears faster. We observe lower memory usage since we enabled the new architecture in application. But the most important is that we see a lot of new possibilities in the new architecture. So, in summary, is Fabric profitable? Yes. The new architecture delivers us plenty of awesome features and new possibility. Personally, I'm so curious how our community will take advantage of the new architecture.
So to sum up, Fabric migration is not an easy task. This is a process, and this process will take some time. Currently, all the code there is to the new architecture is already shipped with React Native version 68. The only limitation is actually the community libraries that still need to be migrated in order to be used in production apps. So that's why we are here. We would like to encourage everyone to contribute to the process because we believe that certainly Fabric is the future of React Native. In fact, Facebook itself uses Fabric in their mobile apps. And Fabric provides a lot of new possibilities, and we are looking forward to seeing what else can be done. And that's all that we have prepared for today, so thanks.
Thank you.